this is Dave with NTI Online, and today we're going to go over ER6 on your TI series boiler. Now, most of the troubleshooting today will be applicable to the 100 all the way up through the 400. There are a couple of small differences when you get into the TI 400, and we'll cover those separately. But for today, we're going to go over ER6, and ER6 is intended to mean that your boiler is failing to ignite. So there's two types of ER6 you want to pay attention to. One is you get an ER6 on the controller, and at some point you notice this red LED is blinking 3 times in a row on the fan wall control. That's the one we're going to concentrate on today, is a 3-flash error. If your boiler is running and goes straight to ER6 while the burner is operating, or if you get an ER6 right away before anything really happens, what I'd like you to do is go to our ER4 video and watch that one, because on older boilers, ER6 and ER4 kind of meant the same thing. So watch the ER4 video if you get no flashing on the fan wall at all. If you do get any kind of flashing on the fan wall, first thing you're going to look for is stick your eye over here and look inside the sight glass. You're going to look for a fairly bright orange glow. If you get no glow at all, check our video on testing your TI series igniter. It could be that you're not getting power to the igniter, which very unlikely, but potentially could be a bad fan wall. More than likely it's just a bad or failed igniter. We've got a video on how to test that specifically. Once you've verified that you do have a glow in the chamber, even if it's only temporarily or only there for a short period of time, the next thing we're going to want to do is basically go up top here, find our safety limit circuit. So there's 2 red wires. There's one up here. Disconnect that. These will be a little stiff in the field, so you may want to have some pliers available. You're going to disconnect both of these. Get a jumper wire. Make sure it's a decent, secure one. And watch that this doesn't touch ground, because we don't want to short it out and blow a transformer. And we're going to jump this out. If you jump this out, reset your call here by double tapping the function button. If you need to, jumper in a call for heat or hot water. If all of your problems go away and your ER6 stops showing up, what that indicates is one of the safeties up at the top here has gone bad. And again, check back with the ER4 video. That one's a relatively common thing to see, especially on older boilers. For the rest of this video, we're going to assume that you've either jumpered this out, and what I would recommend is that you jumper this out and leave it jumpered out until we're done troubleshooting, just so that we know that nothing up here is interfering with the troubleshooting we're doing. So now that we've verified that our igniter works, the next thing is we need to find out, are we getting gas into the chamber? Because for some reason this boiler is failing to ignite. So either the igniter's not hot enough, we're not getting gas into the chamber, we don't have enough gas, or potentially the boiler is in such poor condition because it's dirty or poorly maintained that it's unable to ignite the flame. Once you've verified that your safeties and your igniter are working, you're going to want to make sure that your venting is in good condition. Now, there's a couple of ways to do this, but really the only best way is to disconnect the air intake pipe, examine it for blockages, leave it breathing room air until you're done troubleshooting. So to that end, I brought a 5/16 ratchet or an 8mm, and you're going to loosen the coupling here on the air intake. This is a band coupling. If you have some of these will have a 1/4-inch screw in the end here. You can also take your 1/4-inch nut driver and remove that screw to remove the air intake. So you pull the screw right out, and then you can pull the intake off right at the elbow. That is going to be fairly stiff in most cases, so usually I just like to remove it right from the coupling here. If you've got an older boiler, this will be a black elbow. And if you do have a black elbow, be very careful you don't break this piece of tubing. That's quite brittle. But you want to make sure there's nothing in here. This needs to be completely clear, no birds obviously. Once you go to reassemble this, you're going to put this back together. And if you need to, don't be afraid to cut the venting below the boiler and put a Fernco on there. These need to be serviceable, so there's nothing wrong with putting a removable coupling here so that you can service this in the future. But none of this is clear until you physically look through the intake. You can see into the venturi, run your finger inside the venturi, look for black sooty residue. If you have that, you might have a damaged venturi. Of course, make sure there's nothing in there. You do need to have this pipe connected in order for the air switch to work, so we'll hook that back up now that we know it's clear. Testing your exhaust is a little more tricky. You want to make sure you look all the way outside, make sure the bird screens are in place, and look for any bellies in the piping. If the piping has sagged over time, it can fill with water, preventing your boiler from breathing, and that is going to cause you a lot of headaches. Next up, we know we've got a clean intake, we know we've got a clean exhaust, we've bypassed the safeties, we're confident the igniter is working. At this point, we want to remove the burner door and see our video on cleaning the boiler. You want to get inside, thoroughly flush, scrub, and clean that combustion chamber. And if needed, you can get inside the extended air tube here and inside the burner and clean that as well. Over the years, these will fill up with mosquitoes and bugs and dust and dirt, and that can give you lots of ignition problems. Now that we know all that stuff is good, we need to move to the next step, which is to verify, are we getting gas and are we getting enough gas? So to do that, what I recommend is find your valve here. There are 2 test ports on the valve. The test port that is closest to where the gas line enters the valve is your gas line pressure. So what you're going to do is get your manometer out, turn that guy on, set him to inches of water column. There we go, inches water column. And we're going to connect onto the one in the back here, which is our gas inlet pressure. So you'll want a flat bladed screwdriver, a fairly sturdy one. These 2 screws do tend to be very tight. I'm going to reach in from the side here. You're going to loosen that off approximately 2 full turns. And you're going to connect your manometer tubing up to that port. So once you're on the port, you're going to be looking for standard gas pressure. So for natural gas, it's between 4 and 7 inches or 4 and 8 inches. If it's propane gas, it should be between about 9 and 12 inches. If you're outside of those ranges, check your gas line, figure out why you're outside the range, correct that first, then come back and try again. And what you want to look for is when you run your boiler through your ignition sequence, you're going to see the burner light come on, you'll hear a click, you'll see the igniter go, you'll hear another click from inside your fin wall control. Look for a dip or a change in gas pressure. You should see approximately a half to maybe 1 inch change in gas pressure. You should never go below the minimum of 4 on natural gas or below the minimum of 9 on propane. If you do go below 4 or 9, again, check your gas line, you have a problem there. If you get a nice, consistent, steady pressure drop for about 5 seconds, that means your valve is getting energized and it is opening. If you get no pressure drop at all, or if you get a very slight pressure drop, maybe 0.1 inches, something like that, it might indicate that either your valve is not opening at all or it's not getting power. So you want to listen for a bit of a clunk from the valve here, and you're then going to want to remove the gas valve harness, and we need to check to see if we're getting voltage out. So what you want to do is you're going to test the 2 outer pins here. I've got a specialty harness that I've made for this. You want to get something with a fairly small tip that fits right inside there. You want to hook those up. You're going to connect that to your voltmeter, and you're looking for 24 volts DC coming out of this while the ignition trial is going on. You should expect to see that 24 volts while the igniter is glowing. So the igniter will glow for about 1-2 seconds, 3, 4, 5, 6, roughly. You're going to get gas and igniter. If you don't get any 24 volts out, you're going to follow this harness back. You're going to find the brown wire, which goes to your terminal strip here, and you want to measure from that terminal strip to ground using your voltmeter. I'll plug that back in and show you that next. So we're going to set to AC volts. Going from the brown screw terminal to ground, you can use the chassis ground, looking for AC volts. You want to see if you get 24 volts coming out. If 24 volts is coming out, nothing comes out of the harness, you have a bad harness. And lastly, if you are getting power to this harness, but your boiler is still not lighting and you're fairly confident you're getting a good either pressure drop or you're getting a good clunk from the valve, it may indicate your boiler is just severely out of adjustment. So to reset the valve or get it close to a factory setting, you're going to find the high fire adjustment screw. You're going to turn it all the way clockwise till it bottoms out, and you're going to back it off 6 to 7 complete revolutions if you're on natural gas. If you're on propane gas, you're going to start at about 7 revolutions, allow your boiler to try and ignite, wait for it to lock out, back it off 1 more full revolution, try it again, and try it again. If you start getting up around 12 turns, you've effectively maxed out the valve. Any further adjustment is really a waste of your time at that point. Something else is wrong, and we need to figure out why the boiler's not lighting from that point. So that goes through probably the most common things that we see, which is going to be something to do with the safeties. These igniters last about 2 years, 3 years sometimes. If your boiler lights and goes out every single time, and you get a nice clear blue flame, you've checked the intake, you've checked the exhaust, it's all clean, you could have a bad flame rod, so certainly try and replace the flame rod. And although it's very rare, it is possible you could have a bad fan wall controller, but that really should be one of the last places you go. If the igniter glows and the burner lights, there's probably a 99% chance that fan wall is working just fine. You can inspect your flame probe wire here. To do that, disconnect both sides, and this should have somewhere between 10 to 15,000 ohms of resistance. So we're going to go up to resistance, check for a bad flame probe harness, which is pretty rare, but occasionally will happen on an older boiler. And so this one gives me about 8.5 kilo ohms. That's well within the normal range, so I would say that flame probe harness is fine. You can also clean these. However, if you do happen to clean it, what I recommend is that you replace it shortly afterwards. We found that once you start cleaning these, they tend to fail a bit quicker because the dirt likes to stick to them a little better. And once you're sure that you've got everything back to normal and everything working, you want to make sure you reconnect your safeties. It's never safe to operate the boiler with these bypassed without supervision. So we're going to reconnect all of our safeties, and hopefully your boiler's been put back into service. Now, one thing that is a little strange from time to time, if you're not the first guy on site, make sure that this fan wall, or if the fan wall has been replaced, make sure the wiring is correct. We're going to show you a photo of the correct wiring. It's still a rather common mistake. Somebody replaces this and they get the L1, L2 is commonly reversed, because the naming would suggest that L2 is your white wire. However, in a lot of cases, it will get miswired, so make sure that you wire it as shown in the photo here. Now, last off, and probably the most rare, is a faulty optocoupler. The optocoupler is this little device off to the side here. It's got a little red LED on it, and when you look at this, and we'll show you a good photo of it, there's a blue wire, a blue and a green, and a brown on the third position down. The blue wire at the very top effectively senses or tells this controller that the flame is present. If the optocoupler goes bad, your boiler will always go to an ER6. And one way to test this is to take the optocoupler, connect it to a chassis ground, and if your ER6 goes away and your boiler stays lit and running, that indicates you've got a faulty optocoupler. You'll want to put a new one on, or at very least examine these top 6 screws to make sure they're snug and tight. Hopefully that helps you through your ER6. If you have any questions, as always, call us at tech support at 800-688-2575. Thanks for watching the video today. If you'd like to check out more videos, see the link below. Don't forget to like, share, and subscribe to our channel for all the future updates. And also check us out on Facebook, LinkedIn, and Instagram.